Hello. In this video, we will discuss the working of CRO and DSO and their applications. So by watching this video, you will be known some basic knowledge about the CRO and DSO, that is cathode ray oscilloscope and digital storage oscilloscope. So first let us see what are the contents of this video. In the section of cathode ray oscilloscope, first we will see the introduction, then construction of CRO, then its block diagram, its working, then what measurements are taken with the help of CRO and their uses and applications. And in second section, that is in digital storage oscilloscope, its introduction, block diagram, working, its advantages and disadvantages, applications, and in the last we will discuss about the difference between ASO and DSO, that is analog storage oscilloscope and digital storage oscilloscope. So let us start from the CRO section, that is cathode ray oscilloscope. So oscilloscope is an electronic equipment which displays a voltage waveform. Among the oscilloscopes, CRO is the basic one and it displays a time varying signal, or we can say it is waveform. So CRO is typically divided into 4 sections, which are first one is display, second is vertical controllers, third one is horizontal controllers, and last is triggers. So most of the oscilloscopes are used the probes and they are used for the input of any instrument. We can analyze the waveform by plotting amplitude along with x-axis and y-axis. The applications of CROs mainly involve in the radio, TV receivers, also in some laboratory works involving research and design work. And in modern electronics, the CRO plays a very important role in the analysis of electronic circuits. The CROs are used to analyze the waveforms, transients, phenomena and other time varying quantities from a very low frequency range to the radio frequencies. The CRO is mainly operated on voltages, thus the other physical quantities like current, strain, acceleration, pressure all are converted into the voltage with the help of the transducer and thus represent on the CRO. So it is also used for knowing the waveforms, transient phenomenon and other time varying quantities from a very low frequency range to radio frequencies. Now let us see what is CRO, or we can discuss about the construction of the CRO here. So cathode ray oscilloscope, it is an electronic test equipment. It is used to obtain waveforms when the different input signals are given. Earlier, this instrument is called as an oscillogram. The oscilloscope observes the changes in the electrical signals over the time, and thus the voltage and time describe a shape and it is continuously graphed beside a scale. By seeing the waveform, we can analyze some properties like amplitude, frequency, rise time, distortion, time interval, etc. So let us discuss about the construction of CRO. So its constructional diagram is shown here. So if we see here, the main parts of the cathode ray oscilloscopes are cathode ray tube, electronic gun assembly, deflecting plate, fluorescent screen for CRT, that is cathode ray tube, and last one is the glass envelope. So let us discuss one by one. First is a cathode ray tube. The cathode ray tube is the vacuum tube which converts the electrical signal into the visual signal. The cathode ray tube mainly consists the electron gun, which is shown here, and the electrostatic deflection plates. that is vertical plates and horizontal plates. Those are shown in the figure. The electron gun produces a focused beam of the electron which is accelerated to high frequency. The vertical deflection plate moves the beam up and down, and the horizontal beam moves the electron beams left to right. These movements are independent to each other, and hence the beam may be positioned anywhere on the screen. So these are the horizontal and vertical plates. So second main part is the electronic gun assembly. This covers all this section. The electron gun emits the electrons and forms them into a beam. The electronic gun mainly consists a heater, cathode, a grid, and a pre-accelerating anode, which is shown here, a focusing anode, which is shown here, and an accelerating anode. So for gaining the high emission of electrons at the moderate temperature, the layers of barium and strontium is deposited on the end of the cathode. After the emission of an electron from the cathode grid, it passes through the control grid. The control grid is usually a nickel cylinder with a centrally located coaxial with the CRT axis. It controls the intensity of the emitted electron from the cathode. After the emission of an electron from the cathode grid, it passes through the control grid. Sure. The control grid is usually a nickel cylinder with a centrally located coaxial with the CRT axis. It controls the intensity of the emitted electron from the cathode. The electron, while passing through the control grid, is accelerated by a high positive potential which is applied to the pre-accelerating or accelerating nodes. The electron beam is focused on focusing electrodes and then passes through the vertical and horizontal deflection plates and then goes on to the fluorescent lamp. The pre-accelerating and accelerating anodes are connected to 1500 volt and the focusing electrode is connected to 500 volt. There are two methods of focusing on the electron beam. Those are electrostatic focusing and electromagnetic focusing. The CRO uses an electrostatic focusing tube. So third main part is the deflecting plate. The electron beam, after leaving the electron gun, passes through the two pairs of the deflecting plates. The pair of plate producing the vertical deflection is called a vertical deflecting plate or Y plate. And the pair of the plate which is used for horizontal deflection is called as horizontal deflection plate or X plate. Next part is the fluorescent screen for the CRT. The front of the CRT is called the face plate. It is flat for screen sized up to about 100 mm by 100 mm. The screen of the CRT is slightly curved for larger displays. The faceplate is formed by pressing the molten glass into a mold and then annealing it. The inside surface of the faceplate is coated with phosphor crystal. The phosphor converts electrical energy into light energy. When an electronics beam strikes phosphor crystal, it raises their energy level and hence light is emitted during phosphorus crystallization. This phenomenon is called as fluorescence. And last one is the glass envelope. It is highly evacuated conical shape structure. The inner surface of the CRT between the neck and the screen is coated with a aqueduct. The aqueduct is a conducting material and act as a high voltage electrode. The coating surface is electrically connected to the accelerating anode and hence help the electron to be the focus. So this is all about the construction and its main parts of the CRO. So in next section we will discuss about the block diagram of cathode ray oscilloscope. So here on the screen you can see the block diagram. This block diagram shows the general purpose CRO contraction. The CRO recruits the cathode ray tube and acts as a heat of the oscilloscope. In an oscilloscope, the CRT produces the electron beam which is accelerated to a high velocity and brings to the focal point on a fluorescent screen. Thus, the screen produces a visible spot where the electron beam strikes with it. By detecting the beam above the screen in reply to the electrical signal, the electrons can act as an electrical pencil of light which produces a light where it strikes. To complete this task, we need various electrical signals and voltages, and this provides the power supply circuit of the oscilloscope. Here we will use high voltage and low voltage. The low voltage is used for the heater of the electron gun to generate the electron beam. The high voltage is required for the cathode ray tube to speed up the beam. The normal voltage supply is necessary for other control units of the oscilloscope. The horizontal and vertical plates are placed between the electron gun and screen. Thus, it can detect the beam according to the input signal. Just before detecting the electron beam on the screen in the horizontal direction, which is in x-axis, a constant time-dependent rate, a time-based generator, is given by the oscillator. The signals are passed from the vertical deflection plate through the vertical amplifier, and thus it can amplify the signal to a level which will be provided the deflection of the electron beam. If the electron beam is detected in the x-axis and the y-axis, a trigger circuit is given for the synchronizing these two types detections. Hence, the horizontal deflection starts at the same point of the input signal. Now let us discuss about the working of the CRO. So here the basic circuit of a cathode ray oscilloscope is shown here. In this working circuit, we can say we will discuss important parts of the oscilloscope. So first one is vertical deflection system, which is shown in the diagram. The main function of this amplifier is to amplify the weak signal so that the amplified signal can produce the desired signal. To examine the input signals are penetrated to the vertical deflection plates through the input attenuator and number of amplifier stages. Second one is horizontal deflection system. The vertical and horizontal system consist of horizontal amplifiers to amplify the weak input signals, but it is different to the vertical deflection system. The horizontal deflection plates are penetrated by a sweep voltage that gives a time base. By seeing the circuit diagram, the sawtooth sweep generator is triggered by the synchronizing amplifier while the sweep selector switches in the internal position. So the trigger sawtooth generator gives the input to the horizontal amplifier by following the mechanism. Here we will discuss the 4 types of sweeps. Here shortcut generator is shown. So next one is recurrent sweep. 4 types of sweep. First one is the recurrent sweep. As the name itself says that the short tooth is respective, that is a new sweep is started immediately at the end of the previous sweep. Next is triggered sweep. Sometimes the waveform should be observed that it may not be predicted. Thus, the desired that the sweep circuit remains inoperative and the sweep should be initiated by the waveform under the examination. In these cases, we will use the triggered sweep. So next one is driven sweep. In general, the drive sweep is used when the sweep is free running but it is triggered by the signal under the test. And next is the non-sawtooth sweep. This sweep is used to find the difference between the two voltages. By using the non-sawtooth sweep, we can compare the frequency of the input voltages. The next part is the synchronization. The synchronization is done to produce the stationary pattern. The synchronization is between the sweep and the signal should measure. There are some sources of synchronization which can be selected by the synchronizing selector, which are described here. So first is the internal. In this signal, the signal is the signal is measured by the vertical amplifier and the trigger is abstained by the signal. In the external trigger should be present. The line trigger is produced by the power supply. Intensity modulation is produced by inserting the signal between the ground and the cathode. And this modulation causes by brightening the display. Then positioning control. By applying the small independent internal direct voltage source to the detecting plates through the potentiometer, the position can be controlled and also we can control the position of the signal. And last is the intensity control. The intensity has a difference by changing the grid potential with respect to the cathode. Now, in this slide, we will discuss about the measurements taken or measurements by using CRO. So, mainly we can do these 3 measurements by using CRO. First one is measurement of amplitude, second is measurement of time period, and third one is measurement of frequency. So let us discuss first one, amplitude measurement. So CRO displays the voltage signal as a function of time on its screen. The amplitude of the voltage signal is constant, but we can vary the number of divisions that cover the voltage signal in vertical direction by varying the volt per division knob on the CRO panel. And therefore we will get the amplitude of the signal which is present on the screen of CRO by using this formula, that is A is equal to J into NV, where A is the amplitude, J is the value of voltage per division, and NV is the number of divisions that cover the signal in vertical direction. So second measurement is the time period measurement. So CRO displays the voltage signal as a function of time on its screen. The time period of that periodic voltage signal is constant, but we can vary the number of divisions that cover one complete cycle of voltage signal in horizontal direction by varying time per division knob on the CRO panel. And therefore we will get the time period of the signal and which is present on the screen of CRO by using this formula, that is T is equal to K into NH, where T is the time period, K is value of time per division, and NV is the number of divisions that cover one complete cycle of the periodic signal in horizontal direction. And next measurement which can be taken with the help of CRO is the frequency measure. So the frequency f of a periodic signal is the reciprocal of the time period t, and mathematically that can be expressed as f is equal to 1 upon t. So we can find out the frequency f of a periodic signal by following two steps. First one is find the time period of a periodic signal, and second step is take reciprocal of time period of periodic signal, which is obtained in first step. So now here we can see the uses of the CRO. So CRO can display different types of waveforms. It can measure short time interval, and in voltmeter it can measure potential difference. And applications of the CRO are voltage measurement, current measurement. Then we can observe the waveform, we can examine the waveform, we can analyze the waveform, and then we can measure the phase and the frequency of the signal. So these are the applications of the CRO. So all these quantity are converted in the voltage form, that is current, some other speed or strain, etc. can be converted into voltage. So this is all about the CRO. Now in next section we will discuss about the digital storage oscilloscope, which is also used widely in the electrical and electronic engineering field. So first we can say in 1897, that is Carl Ferdinand Braun invented an oscilloscope. And here we already discussed about the CRO, which is used for the display and analysis of different types of waveforms of electronic signal in the electronics and electrical circuits. So the digital storage oscilloscope is also one type of oscilloscope used to display the waveform, but the difference between CRO and DSO is that in DSO the digital signal is converted into analog, and that analog signal will be displayed on the screen of the DSO. In the conventional CRO, there is no procedure for the storage of the waveform, but in DSO, there is a digital memory that is going to store the digital copy of the waveform. So, the digital storage oscilloscope is an instrument which gives the storage of a digital waveform or the digital copy of the waveform. It allows us to store the signal or the waveform in the digital format, and in the digital memory also. It allows us to do the digital signal processing techniques over that signal. The maximum frequency measured on the digital signal oscilloscope depends upon two things. First one is sampling rate of the scope, and second one is the nature of the converter. The traces in DSO are bright, highly defined, and displayed within seconds. So we can say digital storage oscilloscope is an instrument that analyzes the signal digitally and stores the data in the electronic digital memory, and by examining the storage traces in memory, it can display visual as well as numerical values. So it digitizes the input signal in order to have subsequent digital signals. The input is stored in digital memory in the form of 0 and 1. This stored digitized signal is then viewed on the CRT screen after the signal reconstruction in analog form. Here, the digital copy of input waveform is stored and further analyzed using digital signal processing techniques. The maximum frequency that can be measured by using digital oscilloscope basically depends on sampling rate and nature of converter. So, next we will discuss about the block diagram and working of the DSO. Here, the CRT employed in the circuit displays the data stored in the electronic digital memory. As the data in memory is stored in digital form, the signal is reconstructed in analog form in order to be displayed on the screen of CRT. So, from this figure, you can see that an analog input signal is fed into the pre-amplifier unit. This unit amplifies the input so as to raise the level of amplitude of the signal. This signal is then fed to an analog to digital converter and the trigger detector. As the voltage crosses the threshold value, the device starts recording on the application of the signal sent by the trigger unit. The output of the preamplifier is sampled by the ADC at regular intervals. The digital output provided by the ADC is stored in memory at consecutive locations. The recording of signal continues until the memory is full. The DAC employed in the circuit produces analog signal to be displayed on CRT. Any further changes in the applied input re-triggers the oscilloscope, which causes the memory to reset. That means the memory is overwritten with the new upcoming data unless the system is in hold mode. By the application of hold mode, the signal traces can be analyzed by the user according to the choice. The size of the memory unit determines the number of samples stored in it. One can alter the length of recording by changing the sampling frequency of ADC. In the case of digital oscilloscope, many different input channels are used, but the memory available to each channel gets reduced. When all the channels share a common store, this is done through multiplexing. Here, 40 channels oscillators are obtainable commercially, having storage capability of 25,000 dots. Many oscillators employ floppy disk storage capability. At the time of digitization, in order to make sure that no information is lost, according to sampling theory, the sampling rate must be twice as fast as the higher frequency of input signal, failing of which will give rise to the aliasing effect. Although the input is sampled according to sampling theory, aliasing effect can still occur, and this is so because the output is present as series of dots that corresponds to the sampled value. So, digital storage oscilloscope uses interpolation technique for visualization of final waves. So, interpolation technique is a technique that creates new data points with the help of a discrete set of known data points. And it is basically of two types: linear interpolation and sinusoidal interpolation. Now here available dots are there, and here the waveform with linear interpolation technique, and here the waveform with sinusoidal interpolation technique is shown. So let us discuss about the advantages and applications of the DSO. So advantages of DSO is it is the portable unit, it has highest bandwidth. The user interface is also simple. Its speed is high. They possess infinite storage time. The DSOs are easy to operate, and DSO allows flexible display property. Some advantages like complex and high cost also concerns with the DSO. Now, what are the applications of the DSO? So here list is given. So it checks the faulty components in the circuits. It can be used in the medical field. It can be used to measure capacitor, inductance, time interval between signals, frequency and time period. DSOs are also used to observe transistors and diodes wave characteristics. They can analyze TV waveforms. They can be used in video and audio recording equipments, used in designing, used in the research field. And they can also be used for comparison purpose because it displays 3D figure or a multiple waveforms. And it is widely used in oscilloscope. So that can be used for audio and video recording, for radio broadcasting, for signal testing. In circuit debugging, it can be used for testing of the voltage signals. So this is about the digital storage oscilloscope, and in the last slide we will discuss about the difference between analog storage oscilloscope and digital storage oscilloscope. The difference is tabulated here. So digital storage oscilloscope collects data always, and after triggering only the analog storage oscilloscope collects data. In case of digital storage oscilloscope, the cost of the tube is cheap, but in case of ASO, the cost of tube is costly. In case of DSO, for higher frequency signals, bright images can be produced, but in case of ASO, for higher frequency signals, cannot produce bright images. In case of DSO, the resolution is higher, but in case of ASO, the resolution is lower. So this is the difference between ASO and DSO. So this is all about the CRO and DSO. So thanks for watching the video.